In this video, we are going to solve a problem that uses the mean value theorem. First, we're going to verify that the given function satisfies the hypotheses of the mean value theorem on the given interval. Then we're going to find all numbers c that satisfy the conclusion of the mean value theorem. So the function we're given is f of x equals 1 over x, and we're given the closed interval 1, 4. So first, let's recall what the mean value theorem says. Okay, let f be a function that satisfies the following hypotheses. The first one is that f is continuous on the closed interval a comma b. The second condition is that f is differentiable on the open interval a comma b. So if we have a function f that satisfies these two hypotheses, then we know that there's a number let's say there's a number c in the open interval a comma b such that f prime of c equals f of b minus f of a all over b minus a. Or equivalently, we can multiply both sides by b over a and write this as the following. F of b minus f of a equals f prime of c times b minus a. Great. So the problem asks us to verify the hypotheses of the mean value theorem. So that means we want to check conditions 1 and 2 for the function f of x equals 1 over x. Then we're asked to find all values of c that satisfy the hypothesis. So now we're being asked to find all c that satisfy this part. Okay, so let's begin. Our function f of x equals 1 over x, and our interval, our a comma b, is 1, 4. So first we want to check if f of x is continuous on the closed interval 1, 4. Well, what do we know about 1 over x? It's a rational function. So this is the ratio of two polynomials. And what do we know about that? We know that that means that f of x is continuous at all points where the denominator is not 0. So I'll write that down. Now, when is the denominator 0? Well, the denominator is only 0 when x equals 0. So this function f of x is continuous everywhere except x equals 0. Now, is x equals 0 in the interval 1, 4? No, it is not. Therefore, f of x is continuous on the closed interval 1, 4, right? And then I'll say that 0 is not in the closed interval 1, 4. Great, so that satisfies condition 1. Now we want to check condition 2, which is that f of x is differentiable on the open interval a, b. So what does it mean for a function to be differentiable at a point? Well, a function is differentiable at a point, let's say at a point A, if f prime of a exists, meaning the derivative exists at that point. So if we want to know if f of x is differentiable on an interval, that means that the derivative exists for all values in that interval. So in our case, we have f of x equals 1 over x, which is the same as x to the minus 1. We can rewrite it like this. Now, what is the derivative of this? You can compute it using the limit definition of a derivative, or you can use differentiation rules to figure out that f prime of x equals, and I'm using the power rule here, so this becomes minus 1 times x to the minus 1 minus 1. We subtract 1 from the numerator, from the exponent, so this becomes minus x to the minus 2, so this is minus 1 over x squared. Now, where does this exist? The derivative exists at all points except x equals 0. Now, what does that tell me about where this function is differentiable? That means that it's differentiable everywhere except for x equals 0. Now, is that an issue? Well, 0 is not in the open interval 1, 4, so that's not an issue. This tells me f of x is differentiable on the open interval 1, 4. Great, and so this verifies the second condition of the mean value theorem. So now we know that there exists some c there is a number c in the open interval 1, 4 such that f prime of c equals f of 4 minus f of 1 all over 4 minus 1. And the second part of the question is asking us to find all numbers c for which this is true. So let's do this. What is f of 4? Well, f of x is 1 over x, so f of 4 is just 1 over 4. What's f of 1? That's 1 over 1, which is just 1. So this equals 1/4 minus 1 over 3. What is 1/4 minus 1? That's minus 3/4. So we have minus 3/4 over 3. So minus 3/4 divided by 3 is the same as minus 3/4 times the reciprocal of 3. So that's times 1 over 3. So we see that the 3's will cancel out, and we get minus 1/4. So what does this mean? This tells me f prime of c equals minus 1/4. Okay, we're not done yet though, because this just tells me f prime of c equals minus 1/4. It doesn't tell me what values of c I'm looking for. So now what we're going to do is use the derivative. So earlier, above here, we computed that f prime of x is equal to minus 1 over x squared. So in particular, f prime of c, for any c that's in the interval 1, 4, equals minus 1 over c squared. So now I'm going to plug that into the left-hand side of the equation, f prime of c equals minus 1/4. So that tells me that minus 1 over c squared equals minus 1 over 4. Now I can multiply both sides by 4 and multiply both sides by c squared, and can get rid of the negative signs from both sides. And this becomes 4 equals c squared. Now I can take the square root of both sides and get that c equals plus or minus 2. Great. Now what do we know about c? We'll recall that c is in the interval 1, 4. Now this tells us that c equals 2 and c equals minus 2. But minus 2 is not in the open interval 1, 4. So we can disregard this solution. And we see that 2 is in the interval 1, 4, so we keep this solution. So let's go back to what the question was asking. We verified that f of x equals 1 over x satisfies the hypotheses of the mean value theorem on the interval 1, 4, and then it says find all numbers c that satisfy the conclusion of the mean value theorem. So the only c that satisfies the conclusion of the mean value theorem is c equals 2. And that's our final answer. If this video was helpful, feel free to like and subscribe.